Now we have another example here before us, and we have to again tell the order of stability in this. Now, let us just see that all of them are having carbocations. So this is the first one, this is the second one, and of course the third one. As you can see that they all are carbocations because they all possess a positive charge on the carbon. You can see here the positive, and this the last positive charge. But we have learned one thing in the previous videos, in the previous slides, that if the carbocation is on the ring itself, then no resonance occurs. So, we know carbocation can participate in resonance, but if the carbocation is present on the ring itself, then there is no resonance that is occurring in the particular species. So here you can see that the carbocation here, as well as in this case and the third one, all of them, the carbocation are on the very ring. So none of them will show resonance. No resonance means there will be no plus M or minus M effect. So no mesomeric effect also. So now we are left with only one effect which will be of value to us, and that is because of oxygen here. So we have oxygen, we have OH, and we have OH group in all the three places. Now, OH group, because of the electron negativity of oxygen, behaves like an electron withdrawing group. Electron withdrawing group. And thus, they lead to something known as the minus I effect. So each of them which has OH shows a minus I effect. So we have minus I here, we have minus I on this one, and we have minus I on this one as well. So each of them is showing minus I effect. Notice that there is no mesomeric effect, so we are not distinguishing between any one of them as to which one gets to be in resonance or not, because none of them will be in resonance. Okay, now the order of minus I effect, if we see here, the order of minus I effect, if I write, is decided by one factor, which is it depends on distance. The more the distance, the lesser the minus effect. The more the distance from carbocation, of course. So let us each compare the distance. So we can see that in the first case, OH is the closest. The minus I effect is the closest to the carbocation. It further moves a little to the meta position in the second case, and it goes on to the para position in the third case. So ortho, because it is at ortho in the first case, so it shows the highest minus I effect in the first case. So the order of minus I effect, if I have to write, I'll say that the minus I effect in the first one is greater than the second one is greater than the third one. But we are not being asked the order of minus I effect. We are being asked the order of stability. And we know for a fact that more is the minus I effect, more is the electron withdrawing nature, and more electron withdrawing nature. EW is electron withdrawing, so more is the electron withdrawing nature. And thus, more is the destabilization of carbocation. So, what happened is the more the minus I effect, that is nearer the OH to the carbocation, the more is the electron withdrawing nature, and hence more is the destabilization of the carbocation. Now we want our carbocation to be stabilized and not destabilized. So the order of minus I effect, the order which was shown for minus I effect, will just be the order of stability will just be the opposite of this. So the order of stability that we want in the question will be 3 is greater than 2 is greater than 1. If I go on marking it in this question, it will be that the third one is great than the second one, and the second one is shows a greater stability than the first one. Why? Only because of the distance due to the minus I effect. The more the distance, the less is the minus I effect. Less is the destabilization caused by the minus I effect, and thus more is the stability of the species. So the final answer that we want is 3 is greater than the first, second is greater than the first. This was the final answer of the question.